one. All right, so let's take a look here. Last time we did several of these. We did the whole first section, and I think like one of the second section. So what we did last time was the brute force attack, where it tried 400 and something usernames until it found the right password and it got in, and then they were able to upload a malicious image. So, right now we're going to find the IP address performing the brute force attack. I'll pick up this one. This is fun. So let me shove this to the side and move this a little to the side so I can see them more or less at the same. Okay, so here we are. First, we're going to find the HTTP events using the post method. Now remember, actually I can do it this way. I don't even need to recover anything. I can do data summary here. And the source types include HTTP here. So I can just click that. Now I'm going to get all the web data. Now I'm set on the last 24 hours, which is not showing me anything. So first I'm going to turn on sampling, 1 to 100 to make it faster. And then I'm going to go to all time.
1 to 100 is every 100 events, correct?
It's random, unfortunately. So if you run it again, you'll get a different, it's a random sampling of 1%, which is kind of screwy. But anyway, now...
How do you know it's random? I mean, how is the random, who's doing the randomizer?
It does. It chooses, somehow it does a random sampling. If you run it again, you'll get a different number, like 237. If I just run it again, I think I'll get a different number. 261. So it's like a 1% chance for every line, and therefore you get a number that's approximately 1%, but not exactly. And that, I think, is because if it was every 100th event, you might miss a whole systematic thing. There might be a chain of repeating events where the important thing is always the 50th, and if you do every 100, you'll never see it. So random sampling is a better way to sample the data. Anyway, here I get, so I have HTTP events. Now, I want to get the HTTP events using the post method. So I'll go down here and find the HTTP method. And there's post, get, and head. These are the common methods. As you see, post is the most common. But if I click post, it will add that to the query. So now I'm getting the post method. Okay, and now there are 15,570 of them. So I'm going to turn on, I'm approximately 1% of that. So I can turn off the sampling and see if I get the right number. That's why I quote those numbers a lot, because you know if you're on track, if you get the right number. And it's taking more time, but it gets 15,570, which is what it should. So I'm on the right track. Now, I want to exclude the events from the vulnerability scanner. Last time we found they ran a scanner called Acunetics against this. So the easiest way to get rid of it is just the grep search. You just do not Acunetics. And by the way, this ought to turn orange, but somehow the color is turned off on this thing, and I don't know how to fix it. Acunetics, you got to spell it right. Now it'll find events that don't have this word in it. Acunetics. So that should go down from 15,570 to something smaller. And I got to go, all right. And it went down to 441 from 5,570, which makes sense because the vulnerability scanner sends a lot of events, a lot of requests, thousands per second. So that would be a lot of them. So now I'm down to only 441 events. Yeah.
Sam, I see this error. It cannot get username when all users.
Yeah, I don't know what that means. Happens a lot. I just ignore it.
All right.
I think it has to do with me being in the free version and something how that fouls up the user accounts, which is that admin punishment. Right. But I'm only guessing. There are a few little broken things about it.
Okay.
I get 2 errors too.
What's that?
I get 2 errors.
Yeah, and I just don't worry about it because, this is the way of tech. Like Windows machines, if you ever look in the event log, every Windows machine has 100 things wrong with it. But it's 10,000 things and you don't need them. There's usually a bunch of little things not working. Yeah.
Sam, how did you know that ActQ?
Yeah.
How did you zero on that?
Oh, we did it last time. What we did was just look at the HTTP events. And if you just look at them, most of them are in fact from the scanner. And so you just look at a few events and you'll find an obviously malicious event.
And that is that designation. I'm not sure what.
Yeah, we did it last time. Let me bring it up here. So you look for the name of your web server. Right. These are requests to view your web. And if you just look at a few of the events, pretty soon you'll find a malicious one. This is an attack. Right. .. That's a path traversal attack. And if you just look at the request, it has Acunetics product, Acunetics scanning agreement, and so on. Because they just used the default scanner, which labels all the packets this way because it's a legitimate product and they want to warn your team, this is not a real attacker, this is our scanner.
Got it.
If they were better hackers, they would have removed that, but they aren't. So the brand name is just right there.
Got it.
Yep, that's how we got this. So anyway, all right, good. Now, so we found these things. All right, the brute force attack. So now we're going to examine the form data of the remaining 441 events. See, this is exactly what I wanted to show you. You're asking what a table is good for, and this is where you're going to see it. So here's all the data. These are 441 events that are interesting attacks, but I have all this information about them. Each one of them, and this is sort of overwhelming. So, but the form data is what's interesting, because if you look at the form data, now some of it is strange gibberish because some of these post events are not part of the attack. So the common values up here are not helping me much, but if I look at the rare values, then those are here, and I might there. Notice now I'm getting what I want to see. I think maybe not. That's the form data. Yeah, here's what I wanted to see. Username equals admin, username equals admin. Some of these events are part of the attack. Username equals admin, and over on the right is password. And password equals Arthur, password is Big Daddy, password is Blazer. I want these events. I don't want those other ones. This is the attack.
Where it's trying different passwords.
Yeah, and always trying to log in. These others aren't even login events. They're just other
So I
posts.
see the task.
Yeah, they're like looking up data search engines or something. So I want these ones. So there are ways to get them, and the way I did it was search for so examine the form data, and you can make a useful table there. But first, I want to narrow it down. So I want ones that have this phrase in it: username equals admin. That might be enough to uniquely identify the event I want. So I'd like to highlight it, but it's not letting me do it for some reason. But I can just type it in if I have to. It's kind of unprofessional, but it'll do. Username equals admin. Let's see what that does. I still have 441 events though, so that's not doing it. Now let's start with a table. I'm going to make a table of time and form data. This will be another way to get to the ones I want. I'm going to get this out of there because that didn't help me as much as I thought it would. I'm just going to make the table. Get rid of all the other information. All I want is time and form data. Now, I've got a visualization which is stupid, but it's the statistics I want. Here we are, time and form data. Some of them don't seem to have a timestamp, but here's the others. Now, I don't even know. Oh, it's underscore time. No, that's, how can it not have a timestamp? That is screwy, and that's going to foul me up if I can't get that timestamp back. Let me try, let's look at the raw data again. You really need the time for this, and the time is supposed to be automatically generated. Every event is supposed to have a time. Oh, it's this form data here. I'm only picking out the form data. I don't want that. Okay. Because I clicked form data, it did that. It was just showing me the form data field, not everything. So this should now show me oh, I got rare. Okay. I clicked some things and fouled up my query. There. Now I've got the query that's going to show me all the events and all the information.
Product,
Yeah, now I have time and all that other data.
Right.
Now I can put in pipe table time form data. And the time is an automatically generated field, so it starts with an underscore.
Right, so we'll see the time and then the form data specifically.
Yeah. So here's some with blank form data. Here's some with form data that is not a login. And someplace down here I'm going to see the others. Now I can just go to another page. There's like 10 pages of them. 20 per page, or I can make it more per page, like 50 per page.
Wouldn't you just refine your query here?
Yeah, I would, but I'm going to do that by seeing what I want to do.
Okay.
So let's go down here, and I'm looking for, here it's starting, username equals admin, and this one has the password here, and these ones have the password over here. So they're different, but they do have password equals and username equals admin. So
how do you know that that's not? So again, I'm not great at reading this stuff.
Yeah.
And you're much better at it. But
No.
You have username and the task login return.
Yep, and this has password right here.
Right.
These
so
other ones have other things in the way and the password over on the right.
I see. So that is not happening on the same line. So when you point the password happening on admin.
Well, they're both going to log in because the way HTTP works is as long as the parameter is anywhere in the line, it's okay. But they were apparently generated by some different application. And as we're going to see, these were generated by Python script, and that was generated by real browser.
So the sequence of the task as far as the protocol is
Yeah.
concerned, doesn't matter.
Doesn't matter.
As long as these are included.
Exactly. But it helps me identify what's going on. And so I do say the password equals seems like that might be a good way to select and get the good stuff and not the bad stuff. Let's try that. Let's add in the string password equals.
Yeah, you forgot. Oh,
There, and now I got 413, and now I think I'm good. Here they are. That's all logging in. Username is admin, and I can go to the other end by just sorting. This is the one end of time. Probably the latest time on top is usually the default. So this is 1445. No, it's the earliest time on top. 1445, 48, 46. Oh, they're not even in order. Okay, I got to click it to sort. Okay, now I'm going, I think, forward in time. 21.226, 21.241, 247. This is some kind of script trying hundreds of them per second. A fraction of a second, and I've tried a bunch of them. So this is this is a brute force attack, trying a whole list of passwords, one after another, very quickly.
and all of these protocol strings are now formatted the same because we see the password later in the sequence than we did before.
Yep.
Because you added that to the search up here.
Yeah, I just added something to get rid of the other events that weren't logins, and password equals seem to be a useful thing to add.
Yeah.
And so now I can look at the other. So here I'm clearly running some kind of automated attack that makes many guesses per second. If I sort it the other way to see what happens at the end of this time, then here I have a couple ones here that are doing the password. See, it's trying cool Sammy rock. And then in the last one, there's a gap of about 2 minutes from 46 to 48. And then I come in with a different layout. So that shows you what's going on here is they ran a Python script that tried a bunch of passwords. It found the right password and reported it. Then they went to a browser and logged in with the right password. And that took like 2 minutes to read it here and go move to a browser. And you can tell that another way. If you go back,
So, Sam,
Yeah.
I'm sorry to interrupt,
Okay.
but that 2 minutes, are
Yeah.
we assuming that time elapse is the human kind of interceding there?
Absolutely.
Because the script is done and said, hey, moron,
Yep.
you figured it out, this is your information.
Yep.
So the person gets a notification somehow via their phone or whatever.
Yep.
And they are then getting to a workstation or starting up a virtual machine and navigating to a browser to then do what they're going to do next.
absolutely. And that time could be a big gap. They could let this run overnight and then log in the next day or something, you know. But in this case, they were apparently just waiting for it, and just a couple minutes later, they got in.
Is that a common way to identify when the human intercedes in an attack? Is when there's big gaps in sequence time like that?
And this is how the prove you're human works, like the Google caption. So they just check a box and they say, okay, you're a human, because they're measuring how long it takes you to do that. And if you were a script, it would be like 1/10 of a second. If you're a human, they even watch the mouse moves around, it overshoots. From the way the mouse moves and the time it takes, they can tell you're a human. That's the same. So that's one clue. There's another clue too. If I get rid of this stuff, so now I know there's one event that's different, and it's the one at 1448, and all the others are the script. So I can learn more about these events by going away from the table. And now I can look down here, and one thing that's interesting is the HTTP user agent. There are 2 values. All of them except one are Python. And this one is a real browser.
Right, because there's Mozilla, it's on a Windows machine, you can see which
Yeah.
version of Windows it's running.
Exactly. So
Interesting.
they ran a Python script, and that was the 412. This is the script. That's the login later.
And is it going to tell us the IP where that machine is located?
Yes, we can find that. That's a very good point. So if I select for this, I'll get that one event, and now I have everything about it. And there's the IP. This is the IP the attacker actually logged in from, which might be different from from the place he ran the script from.
Right.
Yeah, and I think there's a few flags you've found in that regard. So you found the IP address performing the brute force attack, and last time we found the executable file name. That's where we left off last time, I think. And so now let's try sysmon and stream. I mentioned this before. The Windows event log is so noisy it's almost useless. Doing the simplest thing, like opening a notepad file, will make like 200 events. So it'll drive you nuts. So you install this optional add-on called sysmon, and it adds log entries that are much simpler and easier to understand. And you can read about them here. Instead of thousands of different events, there's only about 12 events.
And so this is the part where you were talking to us about the Windows kernel and what a mess it is. And this,
Well, the log, yeah. And this,
this application
Yeah.
is excluding all that noise.
yeah,
It's not actually
Yeah, it's-
solving the problem.
yeah, well, it is. It's making a more useful log to help incident responders, which is us.
Right.
So instead of having to wade through a morass of garbage, you get events like this: process creation, file creation time has changed, a network connection, a state change, process terminated, driver loaded. There's only about 12 of these.
My point is that
Yeah.
all the other garbage is still there.
It's still there.
This is just screening out what it thinks is what we know.
It's creating additional events
Yeah.
with a tag, so you
Yeah.
can search them if you want to. You still got all the other stuff if you want it, but you can search here, and often you'll find what you want here much faster. And so you see, there's things here. And the main thing we're going to use is number one, process creation. Every time you launch a program, that creates a process. And as we're going to see, it's designed for incident responders. So not only does it record process creation, it records all the information you really want, like the MD5 hash of the executable. So you can just look it up and see if it's malware. Just right there, which the normal Windows event log doesn't record at all. So we're going to look at sysmon. We're going to find the MD5 hash of the executable file the attackers loaded to the server. Because what they did, they ran the brute force attack. They found the administrator login. They logged into a Joomla control panel, which is a website control. And now you can upload files in that panel. And they uploaded a file. And we're going to find that file name. So we're going to read about, we want sysmon event number 1, process launches. So let's go back to the, here, and go, I'm going to sort for different kinds of data again. So I'm going to go to the raw search and the data summary again. And now I got types of data, and here is sysmon. So there are 1 million events, but there's 270,000 sysmon events. So I just want them, and I'm going to turn on some sampling and go to all time again. All right, so now I actually get some reasonable number like 2,000. Now down here I should have the ID, event ID, and now this, and 1 is the process creation event, which is what I want because they uploaded an executable and ran it. So
How do you know that that is the process executable event?
I just had it. You go to the documentation of sysmon. It tells you.
Okay.
And it's real simple. There's only about 12. Whereas the real event ID has like a 5-digit number. There's thousands of events. It'll drive you nuts.
Okay.
This is so much easier. So I only want the ones with 1. So there's only 1 or 2 of them, but that's 10 of them. That's because I got sampling. I can remove the sampling. And so here's the process creation events on my Windows machine. Now, examine command line to find the correct event. So let's go here. Let's see if I can do it from here. The CMD line is another thing. So here's a sysmon event, by the way. And if I expand it this way, it'll be, here's the stuff it records. Command line. This is the actual command line, like the MS-DOS command line that launched the event. Then the computer, here's the hashes, SHA-1 and MD5 and stuff. Here's the image, the integrity level. Here's the MD5, parent process ID. Very useful information. So, you know, and so I want just the command line, which I think I want the CMD line is even better. Let me get my notes here. Yes, CMD line. All right. So, yep, down here's the lowercase stuff. There's CMD line. And probably the same thing as command line, but anyway, this is just the actual executable command line. So I'd like to see the possible values of that. So what I want to do is go here and find, there it is, CMD line. So there are 100 possible CMD lines here of these are various processes being launched. And you can see a bunch of them are launched many times. Now this is where you asked, why would you use rare? Anything that's launched many times is probably just an automatic system process that goes. These are innocent things like Microsoft WMI is one of Microsoft's abbreviations. This is some kind of internal thing. Here's some kind of PHP thing. Here's more internal Microsoft stuff. So in this case, I think the rare values would probably be more interesting. So let's look at them. And I go to statistics to see here's the rare values. And there's iExplore. And here is something, Bob Smith. Here's Microsoft Word, OneDrive, Scan idle task, WinWord, Acronis. Okay. Now let me see if I let myself any useful. I want to find an executable file. Oh, we found the name of the file before. I forgot about that. We found the file. It was 3791. And let's do this one first and get there. We're going to find the file. This will be, okay. So first we're going to find the executable file name, and we do it by looking at post methods and looking for file name extensions. So, as I mentioned before, this is why you keep notes. I'm going to save this in a notepad file or a text editor. There. That's the query I was working on, and I realized I'm on the wrong track. I have to go do something else first. So I've saved it there for later. Now I'll go back to here, and I want to do the HTTP events. So I go to the raw search and the data summary and the source types, and I find the HTTP events, and I'll turn on the sampling and go to all time. So there's all the HTTP events. Now I want to get rid of the ones from the vulnerability scanner. All right, and that's getting me some, and I'll get rid of the sampling. So there's the events. And now I want to find executables. Oh, I wanted posts, I think. Yeah, post, not vulnerability. So let's get rid of the ones that are not post. That's HTTP method. There it is. I only want the post. Now I'm back to those 441 events we saw before. And I want to try executable, so let's try .exe. Was there an executable referred to in one of these events? And there were two events that referred to an exe, and the simplest thing is just search on the page with Control F to .exe. So here you are. There was a directory of some kind printed up with 3791.exe, and here's a file name being uploaded, and here it is again, a part file name, and here's going, so we went to a PHP file and uploaded this file. This is the executable that they uploaded from the Joomla control panel after guessing the password. So this is the malicious file they executed to my server. So I want to add that to this query I was doing before. Now I know the actual file name, so I want to just see event ID 1, and I want to have that appear in the query. Now I'll find the, I got extra junk here. Let's get rid of the charge return there. Okay, this is going to find the sysmon logs for that executable that I just found out about. There. Find when did it actually execute that file.
So again, it's the source type is from what we saw from,
sysmon.
Go ahead.
Yeah. Sysmon.
Sysmon.
Event ID is launching a process.
And we found that by going to that post section,
Yeah.
filtering out, and look. Okay. Yeah.
Yep. So there we are. And so now it only finds 5 events, and I can probably just read them. Here's 3791, and you'll see here's some hash values. So maybe it's easier if I expand it. There. So here, and in fact, if I look at hashes, if I go down to MD5 hash, for example, there are only 3 values. And what happens is the way this works is you will get, even though it only ran the program once, when you run a command line command, it runs CMD. That's the parent. And then the other thing runs as the child. So you have several possible hash values. You have the hash of the executable itself. You have the hash of its environment, which is like CMD or con or something. So one of these is the actual executable itself. The other 2 are associated processes that launched along with it. And
would you assume that the one of the
it is
one of the single events rather than the 3 events?
Well, I don't know. I've tried to actually I always forget. If you read these events in detail, you might be able to figure out which one is right. But when I get down to 3 choices, I just try them all until I find the one that works. But if you actually want to understand it, then I'll make an attempt to explain it, although I'm not too convincing at it. But if you look here, you'll see source type. Here's the command line. This was cmd.exe. So this is not 3791.exe. So when you go to the MD5 hash, this is, I think, the MD5 of CMD, not of the actual 3791. So I think it would be one of the others. Let's expand this one.
Sorry, Sam, can you
Yeah.
clarify? I don't use Windows much. What
Yeah.
is the hash exactly for? Is that an encoded number?
No, it's completely outside Windows. What a hash is a fingerprint. You take all the bytes in a file of any size, and you just combine them with a certain pattern.
Okay.
And then you get a unique number which identifies the file. It's used very often to identify if you got a good download.
Right.
You put the hash, and therefore malware analysts use it all the time. They'll make a dictionary on the web of hashes of known viruses. Virus Total is one of the best.
So basically, the hash is for the processor to assign a unique value to any file
Yeah.
for its own purposes of
Yeah.
sorting the data.
Windows does not do them by default. It doesn't use them. Analysts use them to identify a file. For example, there are lists online of all the common files, parts of Windows, all the things that you know are not malware. So you can just download them and not bother looking at them, because if the hash matches, that's just an innocent file. There are also hashes of all the illegal files, like all the child pornography, so you can easily scan files and see if any of them match.
So
They're
once
used to
the
things like
hash
that.
is assigned to a particular file, its unique identifier is fixed?
Yeah, it's not assigned, it's calculated from the file.
Okay, so it's based on the
yeah.
actual
Yeah.
zeros and ones
Yeah.
that make up the actual data in
Yeah.
the actual whatever it is.
Yeah, there's
image.
there've been a whole series of these. The first one was checksum. When this all started, bytes had 8 bits and ASCII only used 7 bits. And you would have either even or odd parity. You would adjust the 8th bit, so the total number of ones in each byte was either even or odd. And that's because the early networks had a lot of errors. So that way, if one bit was flipped in transmitting it, you would know that had happened, because it would change to an odd number of bits instead of an even number of bits. That was the first hash. It's a checksum. Then we moved to CRC32, which is what Ethernet uses, that combines all the bytes in a packet and makes a 32-bit fingerprint. So when you get an Ethernet packet, you get the data and you get a CRC, and your network card checks to make sure they match. And if they don't match, it rejects it and has to retransmit. And for files on the internet, they use longer ones like MD5 and SHA-1 and SHA-2. And they're just a mathematical pattern of combining all the bytes. That's the idea. Yep. And so
Very helpful.
it's real important, very important concept.
Yeah.
So anyway, what I'd like to know here, I think what I'm going to do is make a table to make my life easier here. This, like I say, I have too much data. All I really want is the command line and the MD5. So let's do that. Let's make a table of it. Pipe table, command line, and MD5. I think that should make it fairly easy to figure out what's going on. Okay, here we are. So CMD is this, 3791 is that, and here's other things. So I'm guessing this is probably the right answer.
And Sam, when you're
Yeah.
just typing in table command line,
Yeah.
the actual case values in those headings really do matter.
I think they do. Let's try the getting rid of. I think if I make this lowercase, it won't work. Yep, they matter.
Just like in the database.
Yeah, but if event ID equals 1 or this, if I change the case here, it won't matter. If I make that a lowercase x, still works. On the left, it's case sensitive. On the right, it's not. This Windows did this to us. In Linux, everything is always case sensitive. In Windows, some things aren't, and this creates endless irritation. Another thing is, like, Windows uses backslash instead of forward slash for
Just
directories.
having any exceptions to the rule at all makes it just stay.
Yeah, but I mean, that's the problem. If people would just get organized, well, our life would be easier. But that's why they pay us the big bucks.
People have never been organized. So
I know.
Just
Well,
drop that concept
well, it's
from
because we have capitalism. All the different companies compete, and they all do it differently, and so we end up with a mess of all these different products designed differently. And of course, they even go out of their way to be incompatible, to try to drive the other one out of the market. Like, I know people that still can't open pictures that come from a Mac on their PC because they made it different just to irritate you. So your whole family will go to one or the other.
But see, this is what bothers me is I take these game theory classes, right? They talk about prisoner dilemma choices
Yeah.
and things like that, where companies should, in the concept of the way the simplified game is laid out, make the same commonality choices.
Well, no,
And yet
this
in
is-
practice they don't.
Well, no, this is a famous there's only 10 famous philosophical problems, and this one is called the tragedy of the commons. It's more beneficial for you to manufacture your product and just dump the mercury in the river, because that's not your problem. It'll poison somebody else's kids, but you get your product cheaper. So you benefit more by hurting other people. And the common shared resource is not protected by anybody. That's the fundamental problem. And so, but you're saying the company will want to do it their way to serve their customers. And in fact, it's probably to their advantage to irritate the other people. Like Microsoft got caught doing this. Microsoft did not invent the operating system. They bought it called QRDOS. And in the early days, there was a competing product called FreeDOS. And so they carefully caught Bill Gates. He made emails about this and then lied about them in court. They made emails saying, let's modify Microsoft Word so it won't run on FreeDOS just to irritate those guys and make them buy MS-DOS. And they did that and it worked. And then they got sued, saying that's abuse of monopoly power. And he tried to lie and say he didn't plan this. They said, here's the emails of you totally planning this. So, but I mean, that's another case. You know, it harms the world in general, but it benefits his company. And that's, anyway, so here, I think that's how you can find the actual one. But anyway, I try all three to get in when I get too annoyed to bother with the details. And then here's one where you have to find the correct password and the time interval. I think I'll do that, and that'll probably be enough for today. That was fun. So if we go back to here, it was getting that time sequence. I think I know how to do it. We get the HTTP events that are post and that have password equals in them. That would do it. So HTTP events, which is source types, HTTP, and then I go to all time and sampling just to make it fast. Now I want the post events, which is here, HTTP method, post, and I don't want the Acunetics scanner. Acunetics. And then there were some extra events. Wait, I'm only getting 3. Okay, I got sampling turned on. Okay. I should get 400 and something. Okay. And now I remember it was password equals. Seemed to be a good string to find the events in the attack and nothing else. And now I only want to see the time and the form data. So it's pipe table underscore time and form data, which I hope doesn't have an underscore or anything. We're going to find out. Okay, I spelled form data wrong. We were just talking about this. So let's go back to seeing the events and find out form underscore data. Okay, fine. Yep. So I put back in the stuff I put in the clipboard and put in the underscore. Okay. There. So here's the, now I sort them by time.
And once again, we're looking for that gap at the top.
Yeah, because that gap is a flag. So here, this is the early times, many of them per second. Here's the end. And so now there's so you can see a couple, you can answer a few flags here, a whole series of flags about this thing. One is, what was the first brute force password used? Well, you can just sort and find the earliest one. That's easy. Then you can find the correct password. Well, that's easy because you look at what he logged in with in the browser. That's the correct password. And then you get the time interval within the time he found the correct password and he logged in. And that's a little tricky because it's not this time between this event and that event, because the correct password is Batman. But this is password equals rock because the scanner the scanner kept going a few passwords after it found the right one. So you find the Batman is down here somewhere. So the easiest thing is to just add that to the query. I probably could use password equals Batman, but just putting Batman in the query at all should do it.
And you should get the event, though, that you have where he logged in successfully and the event where the script tried it.
Right. So now I have the exact time in the script found it, the exact time they log in, and I have to subtract these 2 times. And you have to get it down to like the hundredths of a second or something to get the flag right, which is a little annoying. One thing that's kind of interesting is ChatGPT cannot do this. It can't tell you the time interval between these 2 times. I think, by the way, the Chinese DeepSeek can. In fact, let's try it. That's kind of fun. Let's get this data.
Oh, yeah, let's play around with it.
But I think DeepSeek is much better. So now of course, I've done it manually many times. So you get your 2 times here. Okay, there. All right, so you're trying to subtract these 2 times from each other. And so I would just, what I did, the way I did it by hand, is I just said, well, I'll just call 46 the start. So this is going to be 2 minutes and all this. And the next one's going to be 0 and this. And then I just make seconds. 2 minutes is 120 seconds, so I make 125 and this. And then I subtract this. So you can do it pretty easily in Python or a calculator or anything and get it. That's how I did it. And that's more or less what DeepSeek is going to do. I've got DeepSeek running locally on this machine. It's in the machine language class we talk about how to run these locally. I can just do ollama run DeepSeek R1. It is a smaller version of DeepSeek to fit on my Mac, but it runs pretty fast on here. I should be able to ask DeepSeek to give this time interval, and it's sort of interesting. So what is the time interval between these two times?
Did you say delta or difference? Or
Anything like that. Whoops, I hit enter. That's going to foul it up. Now, let me just stop it. And let's, all right, I'm going to stop it. And then /by and restart it, hopefully clearing the Control D. Okay, because it does tend to get stuck. In fact, there's even /clear. Like I ask it a question, and it keeps trying to answer the old question. Clear clears the history. Now let's try that. Clear, to make sure it forgets my previous attempt. Okay, now I'm going to do it here. I'm going to put it all in one line here and get it ready so I don't confuse it. So what is the... I'm going to say time difference in seconds. There, that should do it. And by the way, typos don't really matter. You can spell things wrong and it will figure it out, which is another nice thing about it. So let's see what DeepSeek makes of that. Because ChatGPT could not do this worth a damn.
I don't know, maybe we should try it now because they updated it.
They do keep updating it, and it might be better. You're right. So this is, I thought this, before, it fouled it up incredibly. It had a good plan, but it didn't make 14 hours the same for both of them. It just did that bit of math wrong. We'll see what it does. 14 hours. Looks like at least it's the same answer both times. Okay. Well, there. 92.169. That might be right. That looks pretty right. That does look right. Well, good. And now, that was all think, by the way. This is the new thing about DeepSeek. First, it does thinking about the problem. Then it gives you the answer. So they don't actually, the think they kind of intended not to show you or something, that's what's I call a reasoning model. Instead of just trying to answer it, it first tries to break it into little steps.
Well, what's nice about that is you actually get to see
Yeah.
if the AI is doing it correctly or not. I mean,
Yeah.
I've messed around with both Gemini and ChatGPT looking for queries on specific sort of like general Google searches. Like,
Yeah.
I know that this movie exists and these are the plot points, but I don't know the title.
Yeah.
And it gave, on like 5 attempts, it kept giving me a title of a film that I knew that was incorrect. And I kept
Yeah.
correcting it.
Yeah.
And it took 6 or 7 attempts
Oh, yeah.
before it finally gave me a query for a film that ended up being the right movie.
Yeah.
But I had to go to Google to validate it and make sure.
You know, a couple of years ago, I was at DEF CON, and there's the Telefreaks party, which is greatly sought after. And if you knew somebody, you could get in. But if you didn't know somebody, you could get in by answering an online quiz, which was 20 questions about an old movie called Demolition Man, which is not available easily anywhere. And I never saw the movie, but I just put them in ChatGPT, and I got almost all of them.
Yeah. Well, Demolition Man is famous for a number of reasons.
Oh, I know. Yeah. Now, anyway, so
Absurd film.
yeah. Anyway, yeah, one of the early science fiction movies, a lot of famous actors in it. So anyway.
Early, it's from the 90s.
Anyway, yeah, but anyway, so that's anyway, that's another flag or two, and I think that's probably enough for today. So you've got a time interval, the correct password, the number of passwords it guessed, and all that. And so next time we'll talk about the ransomware attack, which is another separate attack here, where they plugged in an infected USB stick and ransomware and encrypted a whole bunch of files, and you can watch all that happen and figure out exactly how it started. So that's the stuff I wanted to get to today. If you're on track, I'm going to stop this recording.